Hi everyone, welcome back to another episode of LLM News where I go through all the recent and most exciting developments around large language models and AI. First up, we have this big announcement from xAI on their Series B funding round. There's not a lot of details, but it definitely got the attention of a lot of people, especially on Twitter. And this is their official blog post, and we can see that who is involved in this Series B funding round of 6 billion, with participation from investors including Valor Equity Partners, Andreessen Horowitz, and a few other folks as well. And they do call out some of their developments, their recent development at least. Grok 1 in November, Grok 1.5 with long context capability. There's also a 1.5V with image understanding. I'm really excited about what xAI is doing with this Grok model. And they also announce an open source release of Grok 1, which is very exciting, right? Because we like to also see these open models, which helps to accelerate research and so forth. So there's a lot more work to be done, obviously, as they call it out here, like building applications, solutions, optimizations, and so forth. And that's kind of what their focus is going to be. They're going to use this money to build on their first products, to market, build advanced infrastructure, and accelerate the research and development of their future technologies. So pay close attention to what xAI is doing. They are hiring also very talented people in the community, and obviously it's led by Elon Musk and so forth. But I think it's exciting what they're doing and their approach and how this might actually impact the Twitter platform, or X as it's called now. And so I'm very excited about what they're building and what this team is doing around their large language models and even their image models as well. Next up, we have this new paper from Anthropic. It's titled Scaling Monosemanticity, Extracting Interpretable Features from Cloud Tree Sonnet. So there's a lot of interesting research happening around these models. And one area that you often don't hear about is the explainability and interpretability of these transformer architectures and so forth. And it's very challenging to actually inspect what these models are doing internally, because obviously the way these models are structured, right? There's a lot of hidden components and so forth. It's very hard to understand and to actually build methods around this. Every time you see a paper that claims to have some insights into how these models work, we're always very excited to go through that one. And so what they have found out here is that they're able to extract like these millions of features from one of their production models, and I believe this is Cloud Tree Sonnet they're talking about. And the features are generally interpretable and monosemantic, and many are safety relevant. These features represent different concepts. They may represent like people, they may represent like emotions and so forth. That's very exciting, because if you know that you have features like this, how can you control those to get better steerability and to control behaviors of these systems? That's very useful, not only for making these models work better in production, but also making them safer and more responsible as well when we use and build on top of these systems. And they also claim that they found features to be useful for classification and again steering model behavior. Here is one prompt example. I came up with a new saying: stop and smell the roses. What do you think of it? And then the assistant responds. This is what the assistant responds. So it's a better way essentially to control these models and steer them to whatever behavior you're actually interested in getting. So these are the authors here, right? This was published May 21st. And again, they came up with a methodology of extracting these high quality features from Cloud Tree Sonnet, and that's one of their medium-sized production model. And you can see here an example of that. And they also claim here that these features include features from famous people, features for countries and cities, tracking type signatures in code, and so forth. Some features are multilingual, some are multimodal, right, as well as encompassing both abstract and concrete instantiations of the same idea as well. And so they say something like such as code with security vulnerabilities, and abstract discussion of security vulnerabilities as well. And there was this famous example with the Golden Gate Bridge. You can see that the feature activates strongly on English descriptions and associated concepts. And they also activate in other languages on the same concepts as well. So these are kind of the relevant images that they're talking about. Anthropic is a company that's focusing a lot on safety, right? Their whole, the whole vision and selling point is around safer models. And so they claim also that some of these features are useful and related to security vulnerabilities and backdoors in code, bias, lying, deception, and power seeking, all these different things that we see these models perform, and we have a lot of criticism around, and are more related to safety. They claim that these features are kind of related to that as well, and that could fuel more understanding and more research around building safer systems, so to speak. So you can check out the results here, all the methodology and so forth. I'm not going to go through that in this video, but there's a lot of really interesting examples to go through in this paper. Next up, we have the latest model from Mistral AI, Codestral, and this is their code generation model. And here they specify that they announced that this model is fluent in 80 plus programming languages, and it has been trained on a very diverse dataset that includes these programming languages, such as Python, Java, C, C++, JavaScript, Bash, and so forth, Swift, and Fortran. And obviously, there's a lot of interest in code generation models. They're pretty useful not only for like basic and fundamental tasks, but they're useful also for like code generation, which is, I think, one of the more popular use cases of LLMs. And understanding that this is very useful for programmers and so forth. These LLMs can be used now for complete coding functions, writing tests. Could review PRs as well, complete partial code using a fill-in-the-middle mechanism, which is another interesting capability of these systems. So I'm excited to see this announcement, and you can see the comparison here. The human eval is one of the popular benchmarks for code generation and how it's performed. So this one is a 32K context length language model, 22 billion parameter model. And you can see the performance here and how it compares to something like DeepSeek Coder, which I believe was one of the more powerful ones after Llama 370B. Now, we always want to look at not only these results and these metrics, but we also want to look at how practical these systems are. And they have provided really good documentation for that, so you can definitely check that out. They also provide different integrations as well, so you can use this in VS Code, for instance, and any of the IDEs that you're working on. I think there is a JetBrains integration as well. And they have documentation which goes through examples of how to use these models for fill in the middle, whatever you want to use these models for. So I like this approach. I think this is what we are expecting from these companies that are releasing these models. And Codestral is also an open weight model. So the 22 billion is an open model license under their new Mistral AI non-production license. So they can be downloaded from Hugging Face. So exciting release. Check that out for more details. Next up, we have this interesting paper that caught my attention, and I've been following the world of large language models, and I always get excited to see interesting ways or new ways on how these models can be used. And this paper actually makes an interesting analysis on whether you can use small language models to solve long context tasks. And what this means is that for long context tasks, obviously we want to ideally use these long context models that are more trendy today. But the question is, can we use these small context language models or these short LLMs to solve these long context tasks? And apparently they propose a framework called LC Boost, which does provide evidence that you can use these short LLMs to effectively solve all kinds of long context tasks in a bootstrapping manner. What they propose in this framework is they reason for two critical decisions, right? How to access the appropriate part of the context within the input, and how to make effective use of that access context. So there are two parts to this work. And I think this, without going into too much details, this actually highlights the importance of breaking down the task into its individual tasks, because you might be able to solve a specific problem without needing to use a long context LLM, which might give you some latency issues and latency challenges. So you can get away with solving these long context problems with these short LLMs by kind of dividing the task into subtasks and then addressing them like that, right? So, and the reason why this is useful is because understanding the fundamental capabilities of a language model is really important because that's what you're going to use. Those are the insights you're going to leverage to basically create a really good plan and a strategy for how to tackle a task. So in this case, they suggest to use two different steps. And the first step is one is the reasoning of access, right? Where the LLM prompts itself to plan for how to access the part of context within input. So basically, you're instructing the model, right, to find and to plan on how to access the appropriate parts because the context might have a lot of noise, it might have useful information, it might have information that's not useful. So that's an important part that was emphasized here and was discovered to be important for these long context problems. And then the other one is the reasoning of utilize, where the LLM figures out how to make effective use of the access context, right? Once you have access that context effectively, now how to make the most use out of it, right? That may include, I don't know, what kind of reasoning steps. It may include different ways on how to prompt and so forth, right? So how to utilize it. So I like this approach, and I think it's a very simple approach. And apparently, from what they report, their results, they achieve really good performance on their approach using different models and so forth for different tasks. And that's really exciting to see, right? And this goes back to one point that I've been highlighting for so long now, which is don't sleep on these small language models. They're actually, very efficient. They're very useful. They can perform all kinds of tasks. I think we should be spending more time reasoning about the types of tasks that we want these models to perform, thinking about the actual workflow, right? And dividing the problem into like subtasks, into simpler subtasks, and addressing them using a language model that is not resource intensive, right, or computationally intensive, because that could simplify things and that could make things more cost effective. Next up, we have this excellent blog post that was posted in O'Reilly and authored by Eugene and a few other folks that are experimenting very extensively with large language models. So you might see a few of these names and you may be familiar with some of them. I am familiar with all of them, and they're usually posting a lot of interesting insights and so forth, similar to what I do on my Twitter account. So these are, good people to be following for sort of like recommendations on how to best use these models for real world applications, which is something we discuss a lot, in our courses and during these kind of LLM news episodes as well. So what they show here is it's nothing new to me, I would say. I mean, I've had very similar experiences. There are certain things that I do differently, but I think overall, what they're suggesting and their recommendations here, it doesn't look so new to me. I think the way you approach a problem when using or applying large language models, you can really get the most out of these models by understanding, for instance, how to prompt them correctly using something like chain of thought, how to use few shot prompts as well, how to experiment with that, right? Having a really good systematic approach for how to addressing a task. When to use RAG, for instance, as well, right? How to structure inputs and outputs to get more reliable outputs from these models, right? What kind of tools you may want to use for that as well. So there's a lot of these types of topics, and they're all very important, right? How to craft your context tokens as well. So if you're working with RAG systems, right, how do you contextualize information? How do you optimize that context? There are different steps and approaches that you can use for that. And so they go into that as well, the kind of metrics that you use, the ranking metrics, right, such as mean reciprocal rank and so forth, which are very common with information retrieval systems. And there's also the idea of using keyword search in a kind of hybrid setting. So again, nothing new, I would say, but I think their framework and their approach is very relatable for the work that we also do in our consulting business. And so it will be great to actually take a look and go through this really long post that they posted here. They have also some discussion about long context models and why it won't make RAG obsolete. And I've spoken about this and I've tweeted about this so much. And I do believe that. I do believe the case that, we're going to have use cases where RAG makes sense. We're going to have use cases where long context LLMs make sense and so forth. So we cannot just throw away or just disregard a specific approach because I believe we haven't really experimented that well. We barely have any kind of design patterns around LLMs. And I think this blog post kind of highlights that, right? Not to discard any type of approach just because, someone is saying, oh, it's going to get completely replaced by some newer approach. I don't think it works that way in the real world. And so, yeah, check that out. There's a lot of details here, a lot of recommendations and results and so forth. So it's an interesting blog post. Next up, we have this excellent paper. This was, I believe, #1 on Hacker News when it got released. And so it was brought to my attention and I actually read it. And basically what they're proposing is, can they configure or modify the transformer architecture, right, to create a model that can better handle arithmetic tasks. And so that's what they're kind of trying to do here. And the reason for that is because we understand that these models also they have an inability to keep track of the exact position of each digit inside of a large span of digits. So as soon as you have a large span of digits that you're inputting into these systems to do some type of operation like addition, they completely collapse. And so how do we improve that capability? And I like this approach because something that I've been saying for some time now with these transformer models, I think the architecture itself is underexplored. I know a lot of folks that are working on making these models efficient, are still exploring these transformer models. Some folks are, maybe using some other architectures, but I think it's still very much underexplored, and we can create better modifications for these architectures that not only improve its efficiency, like let's say at inference time, extend the length support, but also extend capabilities as well. And this is an excellent example of that. The capability of this case is arithmetic understanding. And so what they say is that they train only on 20-digit numbers with a single GPU for one day, and they can reach state-of-the-art performance, achieving up to 99% accuracy on 100-digit addition problems. And so what they're claiming here is that they have some type of generalization. So you can see here when they use position embedding, Fire is a very common approach for position embeddings, but they compare with their Abacus embeddings that they're proposing, and you can see how accurate it is and how it performs with the length of the operand 2 and the length of operand 1 here on the y-axis, and so how that evolves in terms of performance. So excellent paper. Take a look at the details of this paper. It's a short paper. Next up, we have this new paper fresh out of archive, and this is my favorite type of papers. So chain of thought, as we know, it's a very good approach to elicit the reasoning capabilities of LLMs. There has been many variants of chain of thought, and I think this is an interesting one and a very interesting approach how to combine chain of thought and other ideas that have been explored in the space of LLMs. And so what they're proposing here is a novel symbolic chain of thought, namely CoT, a fully LLM-based framework. That's really important. Notice that they're not using some kind of external symbolic tool or approach, but they're actually using the LLM, fully to create this framework, which is good to see, and integrates symbolic expressions and logic rules with chain of thought prompting. So it looks something like this, right? And there's 3 steps that they are proposing with their approach. And so you can see the example here, but let's read through what they're actually doing. So first, it translates the natural language context into symbolic format. So, you could look something like this, where we have this in translating symbolic premises. So the standard chain of thought, right, goes into this kind of thinking mode and goes step by step and tries to answer the question, right? The question that was asked, or whatever statement is there to check. And instead of doing that, right, what we want to do is we want to kind of use these translated symbolic premises or perform that translation first. And then it says it derives a step-by-step plan to solve the problem with symbolic logical rules. So once we have that information, now we can kind of come up with a plan and to solve, right, the actual problem using those symbolic logical rules. And so that's what you see here in the example, right, using first-order logic. And then it says the third step, followed by a verifier to check the translation and reasoning chain. What I'm noticing with many of these like prompting approaches, there's this verification component, which is really critical for building, very efficient and effective prompting techniques today. I've seen papers actually using the language model to self-evaluate itself and so forth, right? This is what this is about. And in this case, the verifier actually checks the translation and reasoning chain. So like this additional step just to ensure that things were properly generated and properly set up. And I think that's an excellent idea. And the paper goes through kind of examples and so forth and the motivation behind that. Here is kind of an overview of the workflow as well, proposed with the Symbolic CoT framework. So you can see here the translator, here's the planner with the step-by-step plan, and that is passed to the solver. I think this is a typo here. And we have the selected premises, and it can reason about that information, and then you have this last component, which is the verifier itself, right? And then you finally get to the final answer. So I think we're starting to see that a lot of these prompting frameworks will have more advanced components that are useful to solve all kinds of tasks. In this case, I think they're focusing more on logical reasoning from what I can tell. So if we look at the actual results, right, and you can see that obviously their system performs, or their prompting technique performs better than like naive chain of thought and so forth. You can see here from the results. But they're using the data sets that are more for logical reasoning, which is understandable. And now the question is, can this generalize, right? Can this generalize to other tasks and so forth? And so I think with any prompting technique, we always want to test for that. And I think we don't have too many tests like that in this paper, but that's understandable. I think the idea is to have something that can solve logical reasoning, tasks, or tasks that involve logical reasoning, and can improve the accuracy of that. And potentially this could be used as a component inside of a bigger pipeline, so to speak, if logical reasoning is a capability that's required by any kind of problem that you're working on. It's about improving the faithfulness of those reasoning chains and so forth. The one thing I like about this paper is that they actually publish all their prompt templates and so forth for all the different steps and the prompt templates that they're using. Next up, we have this tweet from Toby, the CEO of Shopify, and he's talking about this tool, which we also use as well, promptfoo.dev, for writing evaluations when working with large language models. And so they use it at Shopify. We use it as well for some of our consulting work that we do. And I just wanted to call out this tool. Actually, it's an excellent tool. And I like that Toby actually mentioned it because I've been wanting to highlight this and feature this tool for a long time now. And evaluation, again, is one of the more important parts of working with large language models, measure the quality of these LLMs and so forth, to catch issues with the generated outputs of these systems. And you have to do that in a systematic way, right? And we talk about that in our course a lot. And this is one of the tools that we use. There are many tools out there. You can write your own assessments, your own evaluations as well. But I think this is a really good starting point to improve your prompts and assess your prompts on the tasks that you're working on when working with these language models. And I like their interface, quite straightforward. You can create a data set, you can set up any evaluation metric. You can also be LLM graded as well. You can select the best prompt and model and so forth. And I think this is an excellent service. They even have the command line version for it. And so I just wanted to kind of call that out as well. Next up, we have this PR agent tool. As some of you may know, in the last LLM News episode, I actually covered something from Codium AI as well. And that was more related to a different agent that could automate, test generations. And so they also published this tool, and which is called PR Agent, which is an AI-powered tool for automated pull request analysis, feedback suggestions, and more. So, we when we code, we have these PRs, and we would like to use an agent to help us efficiently review and kind of handle and process these pull requests. And, by using an AI that can provide feedback and suggestions and so forth. And so the way this system is used, it has a couple of commands like describe, which automatically generates PR descriptions. So for instance, if someone is lazy and don't wants to describe a PR, you can use this command once it's integrated into your code repo. And you have also review, right? Adjustable feedback about the PR, possible issues, and so forth. So I think this is excellent and is very useful. I cannot wait to actually experiment with this and to try out some of these features like improve review and describe. And you can even ask questions as well, like free text questions about the PR to get more information about what that PR is if you don't understand it. So I think this is kind of improving the productivity of developers in a way, and I think that's the target here. I like the work that Codium is doing around code generation and all the use cases they're covering, and some of the tools that they're releasing as well. And this one has an Apache 2.0 license, which is always great to see as well, and to see how the community will respond and contribute to this particular agent. Next up, we have from Meta AI this introduction to vision language model. So we know multimodal is really big in 2024. So I think understanding of these technologies and these systems, right, and the architectures that are used, all the concepts, methodologies like Clip, Flava, and all these different things are really important if you are getting into this space, right, and you want to understand, what has been the latest developments. I think this is the right guide for you. Be familiar with that work. And again, if you come from the world of large language models like me, you will find this very useful because there's a lot of terminology, a lot of different methodologies as well to be really familiar with. Like in large language models, we have transformers. We have these different architectures, right? Like state space models and so forth. And what is the equivalent in the world of vision? And what are the different tools that are being proposed for vision language models? So that's, I think, a really good paper to take a look and to really understand this space more closely. Next up, we have, again, from one of my favorite educators, Andrew Wang. They recently released a short course on AI agentic design patterns with AutoGen. AutoGen is one of my favorite open source tools and is, released by a few folks that I also follow and have been in contact with. And I think it's really interesting what they're doing. They have a really nice tool that you can use to build agentic workflows, with this multi-agent collaborating with each other and kind of solving tasks. But I think it's what's coming for the world of large language models, right? And how to build more complex systems. And so I think it's a good course to take to really understand where this space is headed and what you can do today with these large language models and how you can combine them in agentic workflows and use them for like planning, reasoning, and solve really, really, really complex tasks. And so next up, I wanted to feature our repo, which is ML Papers of the Week. So the top papers of the week. Every week on Sundays, we highlight all the top papers. I actually cover some of these papers in our LLM News episodes. But if you want to keep track of all the papers, we basically take all of the papers and we post them here. So we have an archive version of all the papers that we have covered. So let's say you're looking for some interesting reads around large language models and AI. You can go here and you can track some of the papers that have received the most attention, are tweeted and discussed a lot, and that I also find very useful in the work that we do, for building applications in the real world. So if you're interested in that, check this out. I think it could be really useful for you if you want to track the top papers of the week. Next up, we have from Karpati. He worked on reproducing GPT-2, which is 124 million parameters, and implemented in llm.c in 90 minutes for $20. So I like Karpati projects always because he's always reproducing things and showing how you can build things more efficiently and so forth. And just follow his work. I mean, I think Karpati needs no introduction, but I really like these projects. They're really inspiring. They're very educational as well. The work that he does is very impactful. So I always like to kind of feature anything that he works on. So that's always interesting. He's doing a lot of like C implementation these days. And so that's also very interesting to get more efficient implementations out of these large language models, right? And so that's what he's showing, and that's where he is emphasizing a lot of his time on. So do check it out. Next up is just this tweet by Tommy, and he's doing kind of a series on AI by hand, and he explains really complex concepts in AI, for instance, the transformer here, how it works, right? How the attention block works. And there's this nice animation of how this works to better understand how the systems are doing something like the attention mechanism. So I like his series. He's doing a few of these, by the way. And so do check out his work. And that's it for this episode of LLM News. Let me know if there was anything interesting that you would like me to go deeper into, because I do also extended videos on some of these announcements and these papers or these tools that I cover. So if you want to see that, I'd love to know what you want me to go deeper into. And please leave a like and subscribe to the channel if you're finding these episodes interesting. And that will let me know if you want to see more of this type of content. Have a good one.